This presentation describes personal experiences and direct effects of exposure to electric and magnetic fields in our home and in others. Our research discovered data from other scientists, and they concurred with our findings. Our objectives are to help you recognize sources of electromagnetic stress in the living environment, to understand the electrical neuroendocrine relationships to cardiovascular disease, and to measure cardiovascular response to EMF. Hopefully, you will be able to help reduce unnecessary suffering from heart disease and hypertension. Hypertension is increasing at every age from 20 to 83 years. The number of new cases increased 11.6 million between 1987 and 2001, and according to the American Heart Association website, they don't know the reason why. Neighbors were concerned when Nextel installed a cellular telephone base relay station on the city water tower. Antennas were on top of the tank, and AC-DC power conversion and signal generation equipment were installed under the water tank. Barry Kennedy had noted in his 2002 book, Power Quality Primer, that switch-mode AC-DC converters deposit a lot of dirty electricity on the utility's neutral wire. So we measured the voltage, current, and frequency from the neutral to ground wire and found that AC, DC, and peak-to-peak current increased each time the generator was heard roaring from our recording site in the park. The neutral wire was bonded to the city water system, so the same voltage and current were measured on the water systems of homes in the neighborhood. Nonlinear loads, such as the Nextel electronic AC-DC converter, are noted for taking their energy from the peak of the waveform. The waveform we captured from Nextel's neutral wire is a classic example of a distorted waveform. Note that the peaks have been bitten off from the waveforms. The frequency spectrum of the Nextel waveform contains generous amounts of 180 Hz, 300 Hz, 420 Hz, 540 Hz, and other multiples of 60 Hz. The fundamental frequency. Current composed of the third harmonic, 180 Hz, the fifth and seventh harmonics were found to be related to the incidence of childhood leukemia in studies by Cohn et al. In Denver, Colorado in 2002. In our earlier research, we had found that milk production of cows decreased as the number of harmonics increased daily. A power quality meter, such as an oscilloscope, is necessary to find the source and frequencies of the distorted current. A simple voltmeter will not measure the frequency and distortion of the voltage and current. Our utility engineers measured the quality of power at our house and reported 40 to 80% of total harmonic distortion on the phase wires from the utility, and commonly 200% Ph.D. on the neutral wire bonded to the water pipes during the 24-hour test. So we had hot wires, hot water throughout the house. Ph.D. exceeded IEEE limits of 5% from all harmonics and no one harmonic greater than 3% of total harmonic distortion. Michigan's Public Service Commission failed to enforce the IEEE recommendation adopted by the legislature and seemed to be unaware of its existence. The neutral wire runs the entire length of our house. It passes through 3 rooms on the main level and 3 rooms on the lower level. The electromagnetic field recorded here ranged up to 320 milligauss and was radiating 10 to 50 milligauss into the living areas of our home. It was similar at 10 other homes in the neighborhood. 4 of our neighbors, all within 200 feet of the cellular phone tower, have hypertension, 2 have pacemakers embedded under the skin, and 1 has a defibrillator, and a 5th has non-Hodgkin's lymphoma, perhaps not coincidental. This frequency spectrum of electrical current on the water pipes in our home shows 2200 milliamperes of peak-to-peak current. Note in the data block the fundamental frequency was 263.16 megahertz. This is radio frequency pulsed or digital current, with each frequency oscillating at 4.97 to 124.13 megahertz or million cycles per second. A Michigan State University electrical engineer measured radio frequencies from several local radio stations on the ground wire and the 836 megahertz cell tower signal using the Agilent spectrum analyzer in our home. The ground wire radiated 10 to 50 milligauss electric and magnetic field, EMF, into the living room and other rooms in our home. Voltage potential from right leg to left arm was measured on channel A of the oscilloscope. Current flowing through an ammeter clamped over channel A lead wire on the stool was measured and recorded on the computer. EMF was measured with a Gauss meter sitting on the floor. Heart rate and blood pressure were measured with the blood pressure monitor Omron. The experiment was repeated 5 times. Current exposure ranged from about 0.5 to 2.4 amperes and is displayed on the upper scale in red, and the average current is displayed and the cursor value at the right in the data box. Induced voltage measured from the right leg to left arm ranged from 118 to 288 millivolts in the lower scale, in blue. The body served as antenna, collecting energy from the electromagnetic field radiating from the ground wire attached to a copper water pipe below the floor. During 35-minute exposure test, heart rate increased from 22 beats per minute, or 36%. Systolic blood pressure increased from 127 to 140, or 10%, and diastolic blood pressure increased from 70 to 140 millimeters mercury, or 48%. These were typical sympathetic neuroendocrine responses to stimulation. No electric shock was perceptible. Diastolic and systolic blood pressure increased and heart rate increased as amperes of induced current radiated from the ground wires below the living room floor increased. The linear relationship was positive for amps, volts, and milligauss EMF in 5 experimental trials. Sympathetic nerve stimulation causes positive response. Parasympathetic nerve stimulation and adrenal fatigue cause negative response or low blood pressure and slow heart rate, as in Addison's disease. Thus, autonomic nervous system ANS responses such as iris quarter may be useful diagnostic tools for electropathic stress. The 46 kilovolt transmission lines radiated 63 to 107 volts on the wire fence below the lines on the utility easement 13 feet from the grain storage and workshop building. OSHA in the U.S. Department of Labor's shocking poster warns, working near overhead power lines can be electrifying. Stay away, stay alive, guard your live parts. However, the utility ignored the danger warnings and built the lines too close to Mr. Chick's buildings and workspace, thus breaching an earlier agreement that all construction and emission standards would comply with IEEE standards adopted by the Michigan Public Service Commission as state law. Appeals to MPSC to investigate the location of wires and enforce the laws were ignored. The voltmeter shows 68 to 107 volts on the wire fence antenna. The voltage from the human body grounded to earth was 0.08 volts or 80 millivolts. Current flowing through the ammeter clamped over the input lead was 8 amperes. This is considered current exposure flowing over the surface of the body. EMF, or the magnetic field, was 4.65 to 4.87 milligauss, 28 inches above the earth, as calculated from average peak current flowing through the lines by Consumers Energy Company's engineers. EMF ranged from 2 to 6.5 milligauss, measured with a tri-field Gauss meter at head height on numerous occasions. Current induced from the overhead 46 kV transmission lines exposed Mr. Chick to 1.6 amperes current flowing through the ammeter clamped over his thumb when he touched the metal door of the grain storage building. Voltage was commonly 5 to 10 volts on the metal building. Electrical engineer William English measured the current flowing through the metal door through Mr. Chick's body from right hand to left hand. The scope meter recorded 1.45 volts RMS in the meter mode. Magnetic field was 4.2 milligauss under the line. Mr. Chick was sensitive to the electric shocks to his hands. Current flowing through the lines 11.9 meters above the earth was 24.3 amperes at the time. Maximum current had been 290 amperes according to company records. The standalone electric field was 235 volts per meter, and the magnetic field B was 5.5 milligauss under the 46 kV lines when rechecked a week later. Voltage ranged from 63 to 107 volts on the wire directly under the lines and was 130 millivolts and 0.04 amperes or 40 milliamperes 600 feet horizontally from the 46 kV transmission lines. Current exceeded OSHA's designation of 1 milliampere as hazardous current on at least 72 acres of land 1/2 mile across the Chick farm. The Chick farmstead was immersed in the electromagnetic field. The body was an antenna while standing under the 46 kV transmission lines. Voltage from the body through the oscilloscope grounded to earth was 80 millivolts, 0.08 volt. Current passing through the ammeter clamped over input A lead was 8 amperes. This is considered body surface exposure since we do not know how much current passed through the body. The body's permeability to magnetic fields is essentially the same as air, according to electropathologist J. Patrick Riley and electrical engineer Clayton R. Paul, Doctor of Electrical Engineering. Paul received IEEE's highest award as author of the textbook Electromagnetic Compatibility in 2006. Mr. Chick wanted to know if electrical exposure to the 46 kV lines could affect his heart rate and hypertension, but local doctors said they knew nothing about the possible relationship. Mr. Chick found an environmental health toxicology center that would test his response to a magnetic field. He engaged Dr. William Ray, M.D., to administer an EMF challenge test. Mr. Chick's heart rate variability was normal when tested before the EMF challenge in the Environmental Health Center in Dallas, Texas. Mr. Chick's heart rate variability became arrhythmic during the EMF challenge while exposed to 2 to 4 milligauss EMF. The exposure was less than the 4.65 to 5.2 milligauss he had received while working under the 46 kV transmission lines. The challenge confirms other experimental data, claiming that exposure to electric and magnetic fields produce increased heart rate variability and cause arrhythmia. Mr. Chick's blood pressure increased during exposure to 60 Hz, 2 to 4 milligauss magnetic fields for 10-minute intervals during the EMF challenge test. Administration of the magnetic field caused blood pressure to increase as reported in over 25 other medical studies. The iris recorder recorded the rate of pupil dilation changes before, during, and after the EMF challenge. EMF significantly changed the rate of pupil dilation during 60 Hz and 0.72 Hz EMF exposure, which is a sign of autonomic nervous system response to EMF. Studies of electric utility workers show that the occurrence of acute myocardial infarcts and arrhythmic heart mortality increased as their exposure time increased. The finding was independent of familial history and smoking of cigarettes. The linear relationship between total or cumulative microtesla magnetic field and death from cardiovascular disease were statistically significant in the studies of some 5,000 electrical workers across the United States. Measured effects resulting from application of a predetermined treatment stimulus is known as a cause and effect scientific method. Cause and effect experiments are considered the most desirable since they show direct effects of the independent variable. Heart rate variability, and blood pressure changed when the test subjects were submitted to electric and magnetic fields in the home, under the 46 kV lines, and during the challenge test at the Environmental Health Center, under the supervision of competent medical doctors. These results confirm similar findings from 24 properly conducted epidemiological studies as found in the scientific references listed below. I am grateful to my colleagues for assisting in these investigations. They are highly qualified in their particular areas of expertise because they have hands-on experience in measurement of human and animal responses to uncontrolled electric and magnetic fields.